Hello students, welcome back. In our last video, we did some pretty awesome stuff for Signal Storm. We built out our gameplay world, we got our colors just right and built our network grid lines, and we made our player. We've got that little tiny target that follows our mouse wherever we move in that game world. Well, in this video, we're going to do some awesome stuff too, but it's going to be more behind the scenes work because our game needs logic. It needs an understanding. It has to know what mode of operation we want to be in. So when we first run our game, we might want to display like a start screen. And then when we press enter or some button to begin playing, we're going to want to show our game world. We want to play the game. And then eventually when we die, we're going to want to show a game over screen. So our game needs to know when to swap one screen out for the other. It needs to keep track of the state of the game. And so we're going to have three different states for our game. We'll have a start state, a play state, and a lose state. And we'll give our program the logic to transition from one state to the other. And when it does, it will take a start screen and replace it with our game world, and then replace it with a game over screen. And we're going to call these start screens and game over screens overlays, because the truth is our game world is always going to be there. And what we'll do is we'll put a start screen over it, and then we'll remove it. And then when we need to, we'll put a lose screen over it. And that's where the name overlay comes from. So let's head to the computer screen and we'll dive into this lesson on game states and overlays. So I have Signal Storm Lesson 2, Game States and Overlays, started our starter file open right here in vscode.dev. But let's minimize this and let's open that file directly. So I'm going to click on Signal Storm and I'm going to come over to lesson number 2 and let's open that starter file. All right, so what do we got? I think we got the exact same file we left off with for the most part, right? Our grid lines are built for our network grid. Our player follows the mouse. It's contained or constrained to our game world. So this is a great starting point. But you notice, as soon as I refresh the page, I'm just thrown right into the game world. There is no start screen. I need a start overlay. So let's head to the code and let's see what we can do here. So here is our mission checklist. First, it says we need to add the game state values. So I'm going to search mission 1, Control F to bring this up. And this puts us, it looks like we're going to make a constant variable. We need to add the game state values for the start, play, and lose state. Use clear names so the game can switch between modes. Well, this constant variable, where do we define our constants? Oh yeah, that's right. This is in our student edit zone. So we can think of this as like a knob, something we can tune or change to change our gameplay performance. So if I come down here, this looks like it's got curly brackets. We've seen curly brackets before. That is going to make game mode an object. How do I know? Well, if I scroll down just a little bit more, we have another object right here, our player object, right? And objects have properties. We had an X property and we had a Y property. So we're going to put some properties in this game mode object. And those properties are going to represent the modes of operation, our game states. And I'm going to use all capital letters to make it clear that these are like important game states that we can be in. So the first property that I'm going to set for the game mode object is start. So I'll have a start property, and then I'll put a colon to give it a value. The value that I'll give it is a string, so inside quotes, and the string will just say start. And then I'm going to give it another property. The next property is going to be the next state, which is play. And I'll put a colon, and to give it a value, I'll put as a string, inside quotes, play. And then one last property. I'll do lose, a lose property to represent the lose state. Now, these are the three properties we'll have, but you know, you could add more to this. Like you could put like, I don't know, a pause state. You could put a, like maybe you got a menu, you could put a menu state in here. All you have to do is just expand this system. By the time we're done writing it here in this video, you should have a good understanding of how this system works. And if you wanted to try to implement a pause system, you could do that. But for right now, we are good here with mission number 1. There's just one small problem that I'm having a hard time with. This object is a constant, which means we're never going to be able to change it. I feel like we need something that we can change, something that can keep track of the state of our game. So one moment it could have a value of start, and then the next moment it could have a value of play. And then when we die, it could have a value of lose. You can't do that with a constant. You can't change its value. So let's go to mission 2 and see what we have. Mission 2 finds us just below the student edit zone in our gameplay variable section. So we have this player that we can change, which is why it's declared with let. And now we get another variable here, another gameplay variable called current game mode. And if you note, we have declared it with let, not a constant. That means we have the freedom to change the value of this variable whenever we want. And right now we are assigning it a value of null. Well, null is just, it's a nothing data, okay? It's nothing. It's an empty data. It's not real. So we want to get rid of that. What do we want to set the variable current game mode to as soon as we start our game, when our title screen's up? Well, we probably want to set it to like start, right? But where are we going to get that value from? Well, if I scroll up here, we just made an object that has all of the possible states of our game. So we are going to access the game mode's properties, either the start property, the play property, or the lose property. So let's do that right here. We're going to say, all right, we're going to create a variable called current game mode, and its value is going to change depending on what state of the game we are in. As soon as the game begins, we are going to be in the start mode. So we are going to assign it a value of game mode. There's our object, dot. And once I put a dot, I have access to all of my properties, the lose property, the play property, and the start property. We are going to do game mode dot start. So we'll set that start mode. All right, so now as soon as we run our game is aware of what mode of operation it is in. It knows it is in start mode. But it's still just playing the game because it doesn't know what to do now that it is in start mode, right? It knows it's in start mode, but we haven't yet told it what to do when it is in start mode. So let's go to mission number 3. Mission number 3 puts us in a function called draw start overlay. Remember, the overlay, the start overlay, is going to be our start screen that sits over this window. We got to make that screen. So right now, let's see what we're doing in this function. No stroke. That means give me an invisible marker so you are not going to see the shape, the outline of the shape that I'm about to draw. And then we call fill. We put some paint in our paint bucket. And we use this constant, overlay BG color. 0 in the red, 0 in the green, 0 in the blue. That is black. And we have an alpha transparency of 0.66. So we should be able to see behind that black, which is really good because we then use it to draw a rectangle, which takes 4 pieces of information: the x coordinate of the top left corner and the y coordinate of the top left corner. That's 0, 0. That's right up here. And then we got the width of the rectangle and the height. Width and height are the width and height of our canvas. So we're going to start here in the top left corner. We're going to go all the way over and all the way down. We're going to draw a rectangle that sits completely over our game world, hence the name overlay. And this is going to be for our start screen. So what do we want to do? We want to draw the title over our game board. Okay. So we just got to make some text. We got to have some text here. Well, the first thing I should probably do, I got a paint in my paint bucket, which is this transparent black. I should change it because if I'm going to draw some other objects, I want them to stand out. I don't want them to be the same color. So let's put some new paint in our paint bucket. Fill, and I'm going to put the text color variable that we had previously seen. It's that nice white color, F4, F7, FF. And I'll put a semicolon. With that paint in my paint bucket, before we make our text, we should probably state how we want to align or position that text in our space. So I'm going to do text align, and I'm going to do center alignment in the X direction and center alignment in the Y direction. So if you look, like all of these strings, when we position them, we're not going to position them here at the left. We're going to position them like in the center of the string. So maybe like right here. And then it looks like I'm already setting my text size to be 18, but for our title, that seems super small. So let's make our text size for the title be bigger. I'm going to do 60. And now that I've configured that text system, I'm going to make a text. So I'm going to call the text function, and I'm going to put the title of my game, Signal Storm. All right. Text objects the text function needs 3 pieces of information: the string you want to render, then the X position. Well, let's see what the X position of all our other texts are. Width over 2, width over 2, width over 2, width over 2. Width, the whole width of the canvas, divided by 2, puts us smack dab in the middle. All right, well, that's a great place to be. Width over 2. I'll keep that going, especially because we're aligning our text in the center. So the width over 2 is the center of our canvas, and we're going to put the center of our strings right there. Then we got to figure out what about our y values. So it looks like we're taking our height of our canvas and we just keep multiplying it by a decimal. Well, when we do this, if you think about decimal numbers, they can go from 0 to 1. So height times 0 is just 0. That's going to be right here at the top of our canvas. And height times 1 is just height. That's all the way here at our bottom of our canvas. So height times 0.5 would be like halfway. Height times 0.25 is a quarter away. Height times 0.75 is 3/4 of the way down. And so what we're doing is we're just stacking these texts below each other, one below the next. So my title, I want it to be at the highest point. So I'm going to do height times 0. I'll do 0.3. Let's do that. All right, I think our start overlay is complete. So now when I refresh my game, do we see that start screen? No, we do not. Ah, that's a bummer. I really wanted to see that start screen, but we don't see it. And the idea here is that just because we wrote this function, think of this function like a set of instructions. Just because we wrote it doesn't mean we are running it yet. We maybe haven't followed those instructions. So the instructions exist, but we actually have to call this function draw start overlay. Maybe we do that in mission number 4. Let's go check. Oh, the answer is no, we do not, because mission number 4 is asking us to draw the lose overlay. So now we're in a different function called draw lose overlay. And I guess this makes sense to me because our overlays, we have a start overlay for our start screen and a lose overlay for our lose screen. And let's see, they're going to be pretty similar. In our lose overlay, we grab an invisible marker so we don't see the shape of what we're about to draw. We put a paint color in our paint bucket, that transparent black, and then I draw a rectangle that sits over the whole game window. Now that that overlay is drawn, I put a new color in my paint bucket, the white text color. I align my text to be center, set the text size to be 60, and when we die, our text is going to say, network compromised. Uh-oh, that's no good. And then we lower our text size and it says, the network has gone dark. Messages transmitted, 0. I like to refer to this as like flavor text. This is text that has a bit of flair to it to kind of build the world of our game that we're trying to use, right? You know, like we say here, like stabilize relay nodes and transmit outbound messages, avoid signal noise and maintain network bandwidth and integrity. It all ties in with the game. I mean, we could just be like, you know, click on things to make the game advance. And here we could just say like game over, but we don't. We use flavor text. Now we want to add a little bit more text in our lose overlay. It says we should show restart instructions because our player just died, but we would love for them to play again. So let's create a text here and I'll say press enter to restart. All right, and I'm going to position it at width divided by 2 for the x coordinate. And for a y coordinate, I'm going to keep the trend of going further down the screen. I'll do height times 0.66. And then we're going to be able to restart the game, but we're also going to be able to go to our title screen. So I'm going to say text press R for title screen. Let's give that a shot. And I'll do width divided by 2. And we'll put it at a height times 0.77. Let's give that a shot. All right. Now our lose overlay screen is correct. So we got a start screen. We got a lose screen, our start overlay and lose overlay, but we're not seeing them at all. So let's try to go to mission 5. Maybe mission 5 is where the magic happens. It says show the correct overlay for the current game state. I think this is what we want to do. Let's go see where it finds us. Mission 5 finds us in our draw scene function. All right. Do you remember the draw scene function is getting called, if I jump to it, by the P5 game loop functions. It's getting called by our draw function, which runs every single frame of our game. The P5 library calls it. So every frame, if we're running 60 frames per second, that is 60 times in a second, we are drawing our scene. All right. So inside draw scene, we draw the background, we draw the player, we draw the HUD 60 times a second. If I didn't want to do one of those, watch, I can just comment out drawing the player. So now that's commented out. My player should disappear. Boop. No player at all. The player's gone. I can get rid of the background. Boop. The background's gone. But that we don't want to undo all the great work we did in lesson 1. So let's bring those things back in. So we have a way to just call draw functions in here. We can just draw stuff. So let's Let's draw our start overlay. So we'll call draw start overlay. I'm going to hit tab for autocomplete. And then to run that set of instructions, I need 2 set of parentheses with a little semicolon at the end. And if I refresh the page now, boom, we get our start screen. How cool is that? Signal storm, stabilize relay nodes, and transmit outbound messages. Press enter to begin. Well, that doesn't work yet. We'll get there. We'll get there. But before we do, this is our great start overlay. We got another overlay, though. We have a lose overlay. So let's draw our lose overlay, too. We'll say draw lose overlay. A nice tab for autocomplete. Parentheses to call and run the code, and then a semicolon. Now let's see what happens. All right. Oh, that's not nearly as good. In fact, this is really bad. It looks like we're drawing our world, then we're drawing the start overlay, and on top of that, we're drawing our lose overlay. So it's like we're drawing way, 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 way too much. We're drawing the game world, we're drawing the start overlay, and the lose overlay. This is bad. I don't always want to draw the start overlay, and I don't always want to draw the lose overlay. In fact, I only want to draw them if we are in the correct game state. And so we're going to introduce a really powerful programming tool here called the if statement. It is our ability to ask a question. So we're going to ask a question by saying if, and then we'll put parentheses here. And in here, we are going to put a question. And if the answer to that question is yes, then this line of code will run. We'll also put another question right here. We'll say if, and we'll fill a question inside parentheses. And if the answer to that question is yes, then this line of code will run. We just have to ask the right question. So we only want to draw the start overlay if the mode of our game is the start mode. So how are we going to check that? Well, if you remember, in mission 2, we created a variable called current game mode. We're going to check to see what the value of that variable is. Now, 1 equal sign assigns a value. 2 equal signs is a loose check for equality, and 3 equal signs is a strict check for equality. So we will do 3 equal signs. Now we want to check to see if it is equal to start. Well, where am I going to get that value from? I can't just write start. Remember, we created a constant called game mode, and that object had some properties. It had a lose property, a play property, and a start property. We want it to be equal to the start property. If that's the case, we'll draw our start overlay. Well, our follow-up question, our next question is going to be something similar. If that current game mode variable, tab for autocomplete, is equal to 3 equal signs for strict equality, game mode dot lose. If it's equal to its lose property, then we will draw our lose overlay. Let's check this out right now. When we run our game, we begin in start mode. We should only see the start overlay. Hey, it's just the start overlay, so that's great. Now, we can make this a little bit better. If this question answers yes, okay? Current game mode equals start? Yeah, it is. So then this evaluates to true, and this code executes. If this is true, this will never be true. We'll never be in the lose mode if we are in the start mode. So there's really no need to ask this question at all. We only want to ask this question if this question was no or false. So the way we sort of tie that together, instead of saying if and then if, we do if and else if. Now these questions are sort of tied together. They're brought together. So this second one only gets asked if this first one did not answer yes. This is going to be really, really nice for us. Now, I'm going to search right up here, and I'm going to go mission 2, because mission 2 is where we set that variable. See, current game mode is equal to start, so we show the start screen. Let's change it to game mode.lose. So now we should show the lose screen. Let's check it. All right, so now the lose overlay is shown. And what if I set it to play? If I show it to play, or set it to play, neither one of my questions answer yes. This question is not going to answer yes, so this doesn't run. This question is not going to answer yes, so this doesn't run. So neither overlay should show, and my game world should show. Perfect. That's wonderful. It's working. Why don't we go back, and I'm going to change the value in current game mode. So when we start our game, we'll be nice. We'll be nice game developers. When we start our game, we will set our game mode to start. I think that's probably the polite thing to do. But mission 5 is now done. So let's go to mission 6. Mission 6 says play mode update. We should only update movement during play mode. Stop the game action while other overlays are showing. All right, let's go see if we can check out this pesky little behavior. If I refresh my game now, we're back in start mode. Okay, so the start screen is showing. But if you look here, I can move my player around. I can still sort of interact with the game world. I should not be able to do that while the start mode is active. I should only be able to do that once I hit enter to begin playing the game. So inside of the draw function, which is called by the P5 library, every single frame, 60 frames per second means 60 times a second, we are asking a question. And that question says, if true, run this code. Well, true will always answer yes as a question. True is always going to be true. So this code inside my brackets here will always run. We are always updating our player, but we don't want to do that. We got to ask an actual question that is sometimes yes, sometimes no. And when it is yes, that's when we want to update our player. So the question is going to be, well, we want to update our player only if our current game mode is play. So let's check the current game mode variable, tab for autocomplete. We're going to check to see if it is equal to 3 equal signs for strict equality. And we're going to check to see if it is equal to game mode dot play. We'll check the play property. Only if that is the case, when this is equal to yes, will we be able to update our player. So when I'm in the start mode, the answer to this question is no. This code will then not run. Let's check it. Let's refresh our page. I refresh my page, and right now, my player does not move at all. He's just smack dab in the center of the screen. You can see him right there, okay? And he is not moving. I can't move him. So we have effectively done that. So now I need a way to transition out of the start mode. Like I should be able to hit enter to begin. And right now I can't. I'm forever stuck in start mode. So we got to change that. That's where mission 7 comes into play. So mission 7 finds us in a brand new function called key pressed. And let's see where this function lives. So we are near that P5 draw function and that P5 setup function. Well, that's because key pressed is part of that P5 library. Let's just talk about all of 3 of these again quickly. Setup will run once when we refresh our game. Draw will run every single frame of our game. 60 frames a second means 60 times in 1 second. And key pressed will run anytime we, the humans, press a key on our keyboard. So if we press a key down, this function will run. It's not going to run if a key is being held down, only in that actual state of pressing the key. So if I press the P button, this key will run. If I press the space bar, this key will run. If I press the enter button, this function will run. Now, when it runs, we get access to the key that was actually pressed. So the first thing that we do is we ask a question. If the key code was equal to enter, meaning did we press the enter key? If that question is yes, we ask a follow-up question. The follow-up question says if the current game mode's value is start, and those 2 vertical bars mean or, the current game mode equal to lose. So let's walk through that logic again. I press a key on my keyboard, so key pressed is going to run. We now know what key we have pressed. We're going to look to see if the key code was enter. If that was true, I did press the enter key, we're going to ask a follow-up question. Is the current game mode start or is the current game mode lose? So remember, when we start the game, we are telling the user in start mode, we're saying press enter to begin. And if it were our lose mode, we'd say, network compromise. We'd say press enter to play again. So when we are in the start or lose mode, the enter key should trigger us playing the game, which means we just need to set our game mode variable, current game mode, to the play state, game mode dot play. All right, let's test this out. So I'm going to refresh the game. Now if I hit enter, I should transition to the play state. Boom! I have transitioned to the play state. This is wonderful. This is perfect. Now I'm going to let you in on a little secret. Because we have no way of actually getting to the lose state right now. There's no way to lose our game. But there is, because inside of key pressed, inside of this function, I put a little secret for us. If I scroll down just a little bit, I have put a debug key. We ask a question, hey, a key was pressed. If the key was equal to the G key or capital G, if Then we ask a follow-up question. If our current game mode is play, so we are playing the game and we press the G key, we're going to set the current game mode to lose. So we can automatically force the game to lose. So let's test this. So here I am, I'm playing the game. I'm going to put my player in this bottom left corner and I hit the G key to force a lose screen. All right, and so now our lose overlay shows. We're in the lose state, so if I hit enter now, I should still be able to transition back to the play state. And you can see that I do. There's just one, I guess, small problem. I don't know if it's a problem, but my player doesn't reset. My player should reset when we reset the game. And so we have a function. I'll show you it because it's going to be really helpful later on, called reset game to defaults. We should probably reset the game to its default values. So really positioning the player is not going to be that big of a deal for us, but other things, as we build more systems of our games out, we're going to want to make sure we reset those systems. So right here, before we switch to our play mode, let's call reset game to defaults. All right, so now let's see if it actually even makes a difference. So I'm going to hit enter to transition to the play state. I'll hit G for my game over. All right, and so now when I restart, it still keeps me here, but that's okay. Knowing that we reset all of our systems is going to be huge moving forward. All right, one last mission. And our last mission involves the fact that when we have a game over, it says press enter to restart or press R to go back to the title screen. Right now, if I press R, that is not functional. So we got to map that keyboard press to transitioning back to the title screen. So this finds us again in our key pressed function. I press the R key on my keyboard, this function is going to run. Well, was the key code enter? No, it was not. So now we're going to ask another question. If what? Well, what is the question we're going to ask? If the answer to that question is yes, we reset our game to defaults, and then we put our current game mode to start, which should show our start overlay. Well, we got to just ask, did we press the R key? And we're going to model this just like our debug is. We're going to say, hey, if key is equal to 3 equal signs lowercase r, or is key equal to uppercase R. That way, if our caps locks is on. Now, if you notice, when we're looking at letters, we can just say key. But if we have something that's not a letter, we use key code. And we can use enter, because enter is a special key. So now, if we press the R key, so this question evaluates to yes or true, then, oh, I got rid of a bracket. There we go. Then the code inside our brackets will run. Let's test this. I believe our game state systems is now fully operational. So let's walk through the whole logic. So here we are in the start state. In the start state, I can't move the player at all. We're locked out of that operation. And once I hit enter, I will transition from the start state to the play state. The start overlay is gone, and now I see my game world. The player is unlocked, and I can play and play and play until I force a game over with the G key, which puts me in the lose state. So now the lose overlay is shown. Once I'm in here, the player is locked out again. I can't move the player, but I can press enter to transition back to the play state. And now that lose overlay is gone. Really good. All right, if I die again, I can press R now to transition to the start state. So when we go to the start state, the start overlay should show. And there it is. Very, very good. Awesome. I think this is a great place to stop. We now have logic and thinking in our program. Our program can keep track of what state of operation our game is in. Are we in the start state, the play state, the lose state? And it can show the correct overlay. It can put the start overlay up or remove it to give us the game world. It can put the lose overlay up and then keep it there until we decide to play again. And this system, it works nicely. We did a great job writing it, and we could easily expand it, because when something works in the simple case, it's easy to build it up. So maybe you want a pause state. So if the user presses the P key, you might want to lock out user movement, like our player movement, and show an overlay on the screen that says pause until they press the P key again. I think that's something you could maybe try to do and implement all on your own. But for right now, we'll keep our system start, play, and lose, because it's exactly what we need for our game here. So with that, I'll stop here, and I'll see you in the next video.